Welcome back to the Woodbridge Geometry Virtual Tutor. Today we'll be working in the right triangles and trig unit. You're going to be able to solve for the missing lengths using the properties of a 45-45-90 and a 30-60-90 triangle. Taking a look at a 30-60-90 triangle, we're going to have a 90-degree angle. And then the other two angles are 60 and 30 degrees. So together those three angles are going to add up to 180 degrees. Always with a triangle, we know the angles have to equal 180 degrees. So we have 30, 60, 90. Every time you have a 30, 60, 90, I want you to create this table here. When you hear 30, I want you to think of L, 60, L times the square root of 3, and 90, 2L. If you can set this up on every problem, it's going to help identify what you're solving for. Then you're just going to transfer this into the triangle. So we know 30 is going with L. So the angle 30 is across from the side L. We know 60 is going with L times the square root of 3. So the angle 60 is across from the side L times the square root of 3. And then 90 is across from our 2L. So 90 degree, 2L. So our sides are L times the square root of 3, and 2L. Every problem you have that's a 30, 60, 90, please set that up. Next, we have a 45, 45, 90 triangle. So we know that the 90 gives us a right angle, and the other two angles are 45 degrees. Again, that is adding up to 180 degrees. If you're looking at this triangle and you're thinking, hey, two of these angles are the same, that tells us something special. This is actually an isosceles right triangle. The word isosceles means there's two sides that are congruent. So since two angles are congruent, the sides across from those angles are also congruent. That's where isosceles comes from. The two sides are congruent. So if we have a 45, 45, 90 degree triangle, we're going to set up our table again, this time for our new triangle. We're going to think 45 is an L, 45 is an L, and 90 is an L times the square root of 2. So again, you are seeing that L goes with 45. So across from 45 is the side L. Well, we have another 45, so those have to be congruent because we know this is an isosceles right triangle. So across from our 45, again, is an L. So you should have two L's in a 45, 45, 90. And then we have 90, which is across from L times the square root of 2. Again, every 45, 45, 90 problem, you want to set up this table. So 30, 60, 90, L times the square root of 3, 2L. 45, 45, 90, we have L times the square root of 2. Let's look at some examples here. So in number 1, first thing we want to do is identify what type of triangle we have. Is it that 30, 60, 90, or is it a 45, 45, 90? We have a 90 degree and a 45 degree angle, so our missing angle has to be 45 degrees. So first thing we want to do, 45, 45, 90. We know 45 goes with L, 45 goes with L, 90 goes with L times the square root of 2. Going back to our triangle, across from 45 is 6, so we're going to put a 6 under that L. Across from the other 45, there's no measurement. However, we know this is a 45, 45, 90, so this is an isosceles right triangle. So our sides that are 45, that are across from the 45, have to be congruent. So that's going to end up being a 6 under that L. And then across from 90 is our variable. That is x. So looking at that table you created, you want to ask yourself, where do we have all the information? We have all the information at 45. So we know 6 is coming from L, so what that tells us is 6 is equal to L. We need to get X. So if we look at X, X is coming from L times the square root of 2. So X equals L times the square root of 2. And then we just got to figure out what is L. Well, we already said L was 6, so we just substitute right in. X is equal to 6 times the square root of 2, and that is your final answer. You can keep your answers in simplest radical form. Number 2. First thing we want to do is identify what type of triangle we have. We have a 90-degree angle. We don't know the other two angles. However, our sides across from the 90, we know is an x, and then the other two legs of the triangle is 9 times the square root of 2. 9 times the square root of 2 equals 9 times the square root of 2, so that means the sides are congruent. Since the sides are congruent, that means our angles are congruent, so this has to be a 45, 45, 90 triangle. So we set up our table. We have 45 goes with L, 45 goes with L, 90 goes with L times the square root of 2. Go back to your triangle. Across from 45 is 9 times the square root of 2. Across from 45 is 9 times the square root of 2. That should always happen on an isosceles right triangle. Across from 90 we know is x. There's our variable. That's what we need to solve. So we have all the information at our 45, so we're going to use this to help us. We know that L is equal to 9 times the square root of 2. So since L is equal to 9 times the square root of 2, we're going to have to use that to help find x. So looking at x, x is coming from L times the square root of 2. We know what L is. L is 9 times the square root of 2, so we just need to substitute in right for L. So we have x equals our L value, 9 times the square root of 2. Still, we have the square root of 2, so we need to multiply by that square root of 2. So let's talk about what happens when we multiply two square roots that are the same. So the square root of 2 times the square root of 2, if you multiply your inside numbers, that's equivalent to the square root of 4, which is just a 2. Or you can say, well, hey, we have the square root of 2 squared. Square root and a square cancel, and we're left with just a 2. So when we do this, we're left with x is equal to 9. We have the square root of 2 times the square root of 2, what we just said came out to be 2. So we have x is equal to 9 times 2, giving us an 18. So 18 would be your x value. Let's go ahead and look at number 3. First thing we want to do is identify what type of triangle we have. So we look at our angles. We have a 30, 60, 90 right triangle. So we go ahead and write down our table. 30 goes with L, 60 goes with L times the square root of 3, 90 goes with 2L. Go to your triangle. Across from 30 is your x value. Across from 60 is 12. And across from 90 is y. You're looking at that table to see where we have all the information. All you're given the information is at 60. That tells us 12 is equal to L times the square root of 3. You're working upwards. We need to figure out what L equals. So we need to get L by itself. Right now you have L times the square root of 3. So the opposite of multiplication is division. So let's divide by the square root of 3. Remember, what you do to one side of the equation, you have to do to the other. So square root of 3 over the square root of 3. Anything divisible by itself or over itself is going to cancel right out. That's going to 1. So we're left with L equals 12 over the square root of 3. We want our answers in simplest radical form, so we cannot leave a square root in the denominator. So we need to multiply our numerator and denominator by the square root of 3. Remember, what we do to one side, we have to do to the other. However, When we do square root of 3 and multiply it by L, we have L times the square root of 3 all over the square root of 3, so that's going to cancel and still go to 1. Then we're left with L. On your left-hand side, you're multiplying straight across. You're saying the square root of 3 times the 12. Just rewrite it so it looks pretty. So you have that 12 times the square root of 3. Pull that right in front of it. Put the square root second. In our denominator, we have the square root of 3 times the square root of 3. We talked about this on number 2. When we have a square root times the square root, that's the same number. You can either multiply the inside, so we get the square root of 9, which comes out to be 3. Or we can say the square root of 3 squared, and a square root and a square cancels, so we're left with a 3. So in our denominator, we have a 3. And the last step here is to ask ourselves, can this simplify? You're looking at the number outside your radical, so we're looking at 12 over 3. Leave that radical or that square root exactly how it is. And 12 over 3 really simplifies to a 4, and we still have the square root of 3 is equal to L. If we go back up to our 30, 60, 90 table, we know L goes with X, so we just found X. So X is equal to 4 times the square root of 3. Then lastly, we need to find Y. Y is equal to 2L. And we found L, so we substitute right in. We're taking that 4 times the square root of 3 and plugging in. And we multiply our outside numbers, so the number in front of the square root. So if the number's outside the square root, you can multiply them, or if it's underneath the square root, you would multiply those two numbers. So we have 2 times a 4 gives us an 8, so y equals 8, and then we still have that square root of 3. 8 times the square root of 3. And there is your final answer. Number 4. First step we do is identify what type of triangle we have. They give us a 45-degree angle. They give us a 90. We know there's 180 degrees in a triangle, so your missing angle has to be 45 degrees. Anytime we have a 45, 45, 90, that tells us we have an isosceles right triangle. So the sides across from the 45-degree angles have to be congruent. So this missing side is 7 times the square root of 2. That's what makes these two sides congruent. So now let's go ahead and set up our chart here. We have a 45, 45, 90. 45 is an L, 45 is an L, and 90 is L times the square root of 2. Going back to our triangle, we said across from 45 was the side 7 times the square root of 2. Across from the other 45 is 7 times the square root of 2. And across from 90 is your x value. We take a moment and we look at our table. We ask ourselves, where is this table completely filled in? So we know 7 times the square root of 2 is coming from L. 7 times the square root of 2 is equal to L. We have L by itself, so we can use that to help find X. So looking at X, we know X is coming from L times the square root of 2. So X equals L times the square root of 2. And we just substitute in. We have our L value, we plug it right in for L. X is equal to 7 times the square root of 2 times the square root of 2. Look what we see again. We see a square root of 2 times the square root of 2. So when we have a square root being squared, we know a square root and a square cancel out. So we're left with what's underneath your radical. So 7 times a 2 gives us 14. X is equal to 14. All right, next we have 5 and 6. What I want you to do here is take a moment and pause this video. Go through, identify what type of triangle you have. Is it a 30, 60, 90, or is it a 45, 45, 90? Set up that table and then go ahead and solve through these. So hit pause and try 5 and 6 on your own. All right, so after hitting pause, hopefully your work that you've completed looks like what I have up on the recording for you. So in 5, we should have identified it was a 45, 45, 90 triangle. Again, that's going back because there's 180 degrees in a triangle. From there, you would have set up 45, 45, 90, L times the square root of 2. Across from your 45 should be an x value, and you are missing one side, but you knew that angle was 45, so isosceles right means you have two congruent sides, so your missing value was an x. And then across from 90, you know that was your hypotenuse, which was 18. So if you go to your table, you are missing your values at 45. So you know 90 was your starting point because you had all 3 pieces filled in, right? We're missing our x values at the bottom. So it tells us 18 is equal to L times the square root of 2. If we're trying to get that L by itself, right now it's being multiplied by the square root of 2. We know the opposite of multiplication is division, so we divide by the square root of 2 on both sides. When we do that, square root of 2 over the square root of 2, it cancels, and we're left with an L. So 18 over the square root of 2 equals L. We know this needs to be a simplified answer, so we cannot leave a square root of 2 in the denominator. So we have the square root of 2 times 18. We just rewrite that so the 18 comes out first. It looks nicer. It's prettier to look at than having a square root of 2 times an 18. So put the 18 out front and then put the square root of 2. In the denominator, we have a square root of 2 times the square root of 2. Again, we know a square root of 2 times the square root of 2 is the same as saying a square root of 4, which just gives us a 2. So in our denominator, we have a 2. We look to see if we can simplify that fraction, and we know 18 over 2 gives us a 9. And then we have 9 times the square root of 2 for our L value. So if you got 9 times the square root of 2, nice job, because this was the hardest type of problem you would have to see. Number 6. First thing we're doing is identifying what type of triangle we have. We know it's a 30, 60, 90. You are missing one angle, but we know there's 180 degrees in a triangle. So 30, 60, 90, L times the square root of 3, and 2L. Across from the 30 was your x, across from 60 was a y, and across from 90 was a 10. You ask yourself, where do you have all the information? All 3 pieces are given to you at 90, so you're missing your x and your y, so we're going to have to solve for those. We know 10 is coming from 2L. That's right above it. So 10 equals 2L. We have to get that L by itself, so we divide by 2. 10 over 2 gives us a 5. So at that point, we know L equals 5. And then if we look back in our table, L is going with x. So really, x is equal to 5. Now we just need to solve for y. So y equals L times the square root of 3, and we substitute in for L. We found L to be 5, so we're left with 5 times the square root of 3 is your final answer. So hopefully those 2 problems went well for you guys. So every time you have a special right triangles problem, set up a 30, 60, 90, L times the square root of 3 and 2L, and a 45, 45, 90, L times the square root of 2, and that's going to help you identify what pieces you are missing and what you need to solve for.